Thank you, everyone, for having us today. My name is Steven Zeiler. I'm an engineer at Ripple Labs. And these are my teammates here, Tori, Brandon, and Stefan. We're all working on the Codius project at Ripple Labs. And so Codius is, it is a standard for attested hosting of software. And that probably doesn't make too much sense immediately, so I want to explain exactly why we're building Codius at Ripple Labs. Our goal is to make it easier for everyone to be able to write and also run decentralized applications. And for instance, we built Ripple as a decentralized application, ideally. It could be run by anyone around the world. It could be run by 20 or 100 different entities, and all of the entities communicate with each other, and it creates a kind of distrusted or more trusted system when it's distributed. So there are a lot of people who want to build decentralized applications, and the problem is they always come down to trying to find hosting providers or people to actually host their applications, and it turns out that you have to trust the person that's hosting the application. For instance, with Ripple, it's hard to find really trusted people to validate all of the transactions and not lie about transactions and make up money. Same problems with Bitcoin. And so we're trying to create a system where you can have much greater trust in the software that's running on different applications in order to make more robust distributed systems. And so that brings me to attested hosting. Our goal is that when we're running software, the host, we can tell people this particular host is running this software, and we can prove it. We can prove that your software is being run because the host actually digitally signs attesting that they're running a particular piece of software. And so let's say that you have a distributed application that you want to put out in the world, and you want people to run it all over the world, and you tell people, this is the exact code that I want you to run. Here's the exact hash of the code, and here are the 50 different hosts that have signed saying, we promise we're running this exact code right now. So the entire community can trust these hosts that they're running a particular piece of code, which builds a much more robust infrastructure for hosting. I can't tell if I'm doing very well, so if there's any questions, I love just feedback questions. Yeah.
So how do they prove that they're running the unmodified code?
Let me maybe actually, I'm mic'd up, I think, so I don't need it.
Yeah. So we're kind of like trying to take inspiration from some of the cryptocurrencies, because like ultimately when you're using a cryptocurrency, so for example Bitcoin, right? You're using miners in order to have a proxy who has witnessed a certain ordering of transactions. And since you weren't online yourself, you were relying on them to tell you which of the ordering was the one that actually happened, so that people don't go send money to someone and then say like, oh, actually I sent this money to someone else, right? So you're trusting the nodes who are Bitcoin miners in a certain respect, right? And so it's all about, if you want to have an application that is very secure or is very unlikely to get broken, it's all about how do you identify a large enough, a diverse enough, a set of nodes that you can defer to that is unlikely to collude with one another, right? So that's the fundamental, where the security comes from. Like when we say Bitcoin's trustless, that's where the security comes from. It's because the miners are a large dispersed group, so it's hard to believe that they would collude. And so similar with Codius, like if you want to have a group of nodes that is running your contract, you can choose a group that for your particular use case is very unlikely to collude against you, because either they don't know each other or they're anonymous or whatever criteria that apply to your use case. If you're coming from a different world than like the Bitcoin world, maybe your criteria are very different. Maybe your criteria are, well, because I know them and I know that they're under certain laws, etc. So it really depends on your use case.
And it's important that
Isn't the problem not that the nodes collude willingly, but that an adversary sees which ones he has to take over in order to attack the contract or the program? So it doesn't matter that you've chosen a bunch of Ripple URLs or something that are unlikely to collude. They're unlikely to collude anyway because they're going to lose something if the system falls down, right? Presumably they're invested in the system in some way. The problem is the adversary can see which nodes he has to take over, by hack or otherwise, in order to cause a problem. I mean, I don't understand how that.
Yeah, so that's your opinion, and if that's your opinion, no, listen, but like if that's your opinion, then that's how you should choose your nodes. Like that's why you use Bitcoin, where the nodes are chosen by proof of work. Like if you wanted to, you could choose an anonymous set of nodes which have done a certain amount of proof of work and say like, okay, these are the nodes that I choose to trust. And then because they're anonymous, because they're, let's say, behind Tor or whatever, they're unlikely to get, for people to put pressure on them, right, because they're anonymous. So again, it always boils down to you're choosing some set of nodes that you're identifying with some algorithm or some other method. And then once you've chosen that set of nodes, you can defer to them in terms of your contract.
And on the other hand, there are nodes that you might explicitly trust that people generally trust. Like we run software on Amazon Web Services, and we, to some degree, trust that they're not going to get hacked. And you can look up the IP and try to hack it. But the point is that we're trying to create a standard for attested hosting so that you can choose either a random set or a trusted set or whatever set that you want. But the point is it's a standard. And they are all signing that they're running a particular piece of code.
Are you building on top of an existing cryptocurrency, or this is a new cryptocurrency? I imagine basically if I want some people to compute something, I can pay them to do this. Is that?
Yeah, so there is actually no cryptocurrency involved necessarily in Codius. It's mainly via cryptographic hashes and signatures to verify that the code is running, though we are building in Bitcoin, initially Bitcoin support, so you can pay for each application with Bitcoin, but ultimately it could be any type of payment system that you use to pay for the hosting.
Yeah, so one really important point is that Codius itself does not include consensus, right? So it does not have a blockchain. Nodes don't inherently agree on some global state. But if you have a specific contract that needs to agree on some global state, then you're free to build something in your contract that looks at any blockchain that you like. Like if you want to look at the Bitcoin blockchain and you want to do things dependent on the Bitcoin blockchain, or if you want to look at the Ethereum blockchain, you want to do things dependent on that, you just write those lines of code into your contract and it will execute, and it will, just like any client to that blockchain would, look at that blockchain, and just like any client to that blockchain would submit transactions to that blockchain as well.
So it's an arbitrary hosting, it's just a hosting system where you can sort of randomly choose nodes rather than having been in the same hosting center.
Right.
It's not really a consensus or a cryptocurrency system, it's just a way of choosing nodes that are related to each other.
Exactly.
Yes,
So
at a fundamental level. And then our goal, additionally, is to create an ecosystem and tools for consensus within these nodes and to make it easier for people to build consenting distributed applications.
Yeah, so just to explain the history of Codius, like where we were coming from, was we kept running into the same exact problem like over and over and over, which is like people constantly propose solutions that require sort of this deferred trust. Like for example, if you read the Blockstream paper, Appendix A, they talk about so-called federated pegs, and they say that some very trusted organizations by the community will run these pegs initially, so you can get things off the ground. There's a lot of other companies that are doing like multi-sign wallets, et cetera, and a lot of these end up just defaulting to centralized solutions because there's no easy way to make the sort of deferred trust a reality, because all of the existing hosting solutions, like think about if you wanted to do something like this, they have mainly two problems. The first problem is if I upload something, or if I want to upload something to a lot of different hosts, they all have different sign-up flows, they all have different payment methods, and so I have to do a lot of work just to sign up for all of them and upload my code on all of them, and then later maintain all those servers. So we're trying to create a protocol which automates that process. And then the second point is if I upload something onto a web host, in general, there are some really cool tricks you can do with things like Amazon, but in general, I have to trust that host. I have to trust the uploader not to later log in and change the code, right? So like hosting generally allows whoever uploaded the code to modify it at will. Whereas like a Codius host, it actually locks down the code after you've uploaded it and then attests to this is the exact container that you've uploaded, and that's what's running. And
So using remote the attestation hardware?
Say again?
Trusted computing modules?
So that's almost like a new topic. So remote attestation is currently most widely implemented as part of the Trusted Platform Group's TPM module. And basically how that works is you have a processor and then you have a TPM coprocessor. And the TPM coprocessor kind of watches what the processor is doing and tries to infer the processor's state and whether that state is good or whether it's compromised. Now, the obvious problem is that if these are two separate chips, you can always just like tap the line between them and tell the TPM chip whatever you want to tell it. And the specification from the Trusted Computing Group basically completely excludes that attack model. They say that hardware attacks are out of scope for this specification. There is an effort within Intel. We're actually talking to Intel tomorrow about that. About Intel SGX, Intel Software Guard extensions, where it's basically the same principle of remote attestation, except that it's built into the processor itself. So taking it back to like how does Codius look at all of this technology? It's like it's something that a host could do in order to convince you to have more trust in them. Right? From our perspective, it's like you choose the set of hosts any way that you want. It can be you trust them because they're dispersed and anonymous. You trust them because they're Amazon. You trust them because there's 100 of them. There's 1 of them. There's 5 of them. You trust them because they do remote attestation. Like for our purposes, we completely abstracted it away. We just say like for your use case, you need to select how you select nodes, and you need to know why you trust those hosts.
Are you?
Yeah. How do you protect? How does this protocol inform the subscriber or the client that there's a problem? How is that?
What kind of problem?
Yeah, so normally if I send a request to a server, I have an SSL certificate or SSH or whatever, and I run a program, and I know that's the program that I installed, and I get an output, I assume that the program ran properly. So if an adversary wanted to attack this, then they would, obviously they have to figure out which nodes to attack, so set that aside. So how do I know that an attack has been carried out and that something has been modified? Like how do I know that it's been attacked?
Right, got it. So I think that like the answer to that is this Codius is really no different than regular hosting, right? Like the same way that you would know that someone broke into your normal server, you would also like I don't know, you might detect that the program is doing something weird. You might exactly what people do now when they have break-ins into servers or server compromises, right? And so similarly, you would do the same thing with Codius. The only difference being that whatever you have uploaded, there's a way to for the server, or the server has an API that tells you what the user uploaded. That's really the only difference. Other than that, it's just hosting. It's even if you look at the amount of code, it's not a lot of code. It's basically just a thin layer on top of hosting platforms.
Okay, so it's like distribution, application distribution almost.
Yeah.
So we're going to go into a break now, so maybe
One
more question.
Yeah, I just wanted to ask, like, is the kind of hosting task, is it like long-term one or short-term one? Like for short-term, like computation, I can imagine I outsource the computation to 5 different nodes and I want to make sure they compute the same result. But if it's like a long-term task, I host the same website on these 5 different nodes, then there's a lot of consistency issues. Like, do you consider that at all, or consistency is not something that it's like basically outside the scope of your project? And if I want consistency, for instance, I have to run Paxos myself.
Exactly, yeah. So it's out of scope for us. We give you enough, like having a hosting platform like this, it gives you enough freedom to implement any consensus that you want. The set of nodes that you choose is not fixed. You can modify that set of nodes as you want. You can have nodes leaving and joining, etc. And so I would say it's totally up to the application developer. And again, to go back to the very basics, like all Codius is attested hosting and a way to standardize the billing and the uploading. And then everything else is up to you. If you want to know more about Codius, go to codius.org. So that's my little plug at the end. Cool. Thanks.
Thank you.